Picture a small wooden ship, alone on the open sea. In every direction, the water meets the sky in a perfect, empty circle. No road, no signpost, no coastline. Just waves rolling on toward a horizon that never seems to get any closer. And somewhere far beyond it lies home, or a harbor, or an island no wider than a village. So how do you find it? For most of human history, with no real maps and no instruments at all, this was one of the hardest problems a person could face. This is the story of how we learned to cross the oceans long before satellites, long before GPS, guided only by the coast, the sun, the stars, and a handful of astonishing inventions. The first sailors solved it by simply refusing to let go of the land. They hugged the coast, creeping from headland to headland, always keeping the shore in sight. A jagged cliff, a lone mountain, a temple standing on a cape, every feature became a landmark, memorized and passed down like a story. Pilots built up an extraordinary mental map of the coastline, which bay came after which, where the rocks hid beneath the surface, how the water changed color over a shallow shoal. As long as they could see the land, they could find their way. But this was slow and it was limited. The open sea, the great shortcut across deep water, stayed closed to them. To cross it, sailors had to look up. By day, their guide was the sun. It rises in the east and sets in the west, and at noon it climbs to its highest point, sitting due south for most of the ancient world's sailors. A navigator who watched the sun could hold a rough heading for hours, reading direction from the angle of the light and the sharp shadows it threw across the deck. It was simple, and it worked, but only while the sun was up. When it sank into the sea and the sky went dark, sailors turned to something far older and far more dependable. The stars, night after night, the same patterns wheel across the heavens, all except one. In the northern sky sits a single steady point, the North Star, almost exactly above the North Pole. While every other star slowly circles around it, it barely moves at all. To a sailor, that was a gift, a fixed direction, hanging in the dark. Steer toward it and you sail north. Keep it over your shoulder and you sail south, and it held a deeper secret. The higher the North Star climbs in your sky, the farther north you are. Without fully understanding why, navigators learned to read their position from the height of that one unmoving star. No, where was the art of reading the sky and the sea pushed further than in the Pacific? Across the largest ocean on Earth, the Polynesians found and settled hundreds of tiny islands, spakes of land scattered across thousands of kilometers of open water, and they did it with no compass, no chart, and no metal instruments of any kind. Their navigators trained for years to memorize a star compass, the exact points on the horizon where dozens of stars rose and set, a map of directions written across the night sky. They read the long ocean swells rolling beneath the hull, feeling subtle shifts in the waves that hinted at land far over the horizon. They watched the flight of seabirds at dawn and dusk, knowing the birds would lead them back toward shore. By weaving together stars, swells, clouds, and birds, a master wayfinder could hold a course across the open ocean for weeks, one of the greatest feats of navigation in all of human history. Then came an invention that changed everything, the magnetic compass. In ancient China, people noticed that a piece of naturally magnetic rock, called lodestone, would always settle in the same direction when allowed to turn freely. By floating a magnetized needle on water or balancing it on a fine pivot, sailors gained something the sky could never promise, a direction that still worked in fog, under heavy cloud, on the blackest night when not a single star could be seen. The idea spread westward along the trade routes, and by the Middle Ages, European ships carried a compass mounted in a wooden housing on deck, called a binnacle, lit by a small lantern so the helmsman could check his heading at a glance. For the first time, a ship could hold a steady course straight through the kind of weather that once would have left it blind. A compass could tell you which way you were heading, but it could not tell you where you were. For that, navigators went back to the stars and the sun and learned to measure them. The key was latitude, how far north or south you had traveled, found by measuring the height of the North Star or the noon sun above the horizon. Arab sailors crossing the Indian Ocean used a beautifully simple tool called a kamal, a small wooden board on a knotted cord held out at arm's length to gauge a star's altitude. Others used the mariner's astrolabe, a heavy brass disc hung from the thumb so that it dangled perfectly straight, while the navigator sighted the sun along a movable arm and read the angle off its edge. Rough as they were, these instruments let a captain answer a vital question: how far up or down the world am I? To take that measurement more easily, sailors invented the cross staff, a long rod with a sliding crosspiece sighted directly at the sun or a star to read its height. It worked, but it carried a painful flaw. Staring at the midday sun to take a reading could slowly blind the navigator. So a clever instrument appeared, the backstaff. Now the navigator turned his back to the sun and read the shadow it cast onto the instrument, sparing his eyes entirely. With each refinement, finding your latitude grew a little safer and a little more precise. As these methods matured, so did the maps. Medieval Mediterranean sailors produced the Portolan chart, a remarkably accurate sea map, crisscrossed by fine lines radiating out from ornate compass roses, showing the bearing from any port to any other. Armed with charts, a compass, and a way to find their latitude, captains grew bold. In the great age of exploration, Portuguese and Spanish caravels left the safety of the coast behind and sailed straight into uncharted water. Down the length of Africa, across the Atlantic, and at last all the way around the globe, the sea was no longer a wall. It had become a road, and yet one piece of the puzzle was still missing, and it was deadly. Sailors could now find their latitude, their north-south position, with growing confidence. But longitude, their east-west position, remained a mystery. There was simply no reliable way to know how far around the world you had actually come. Ships sailed for weeks unsure of their true position, and the results could be disastrous. Fleets ran aground on coasts they believed were still far ahead. Vessels were dashed on rocks in the fog, hundreds of sailors lost in a single terrible night. Solving longitude became one of the most urgent challenges of the age, with huge fortunes offered to anyone who could finally crack it. In the meantime, navigators bridged the gap with skill and patience using a method called dead reckoning. Starting from a known position, they tracked everything they could, the compass heading they were steering, and their speed through the water. To measure that speed, they threw a chip log over the stern, a weighted wooden board on a long rope, tied with knots at regular intervals, and counted how many knots ran out while a sand glass quietly emptied. That single trick is the reason we still measure a ship's speed in knots today. Hour after hour, the navigator combined heading, speed, and time at the chart table, plotting the ship's estimated position by candle light. It was an educated guess, and small errors slowly added up over a long voyage, but for centuries it was the best the world had. Then precision arrived. In the 1700s, navigators gained a magnificent new instrument, the sextant. Using a pair of mirrors, it let a sailor measure the exact angle between the sun and the horizon with astonishing accuracy, holding both steady in the very same view. With a good sextant and a table of the sun's position, a navigator could pin down his latitude to within a mile or two. Half of the great problem was now beautifully solved. The other half, longitude, would fall to a most unlikely hero. The secret to longitude, it turned out, was time. The Earth spins a full circle every 24 hours, which means every single hour of time equals a fixed slice of longitude. If a sailor knew the exact time back at his home port and compared it to the local time at sea, read from the sun overhead, the difference between them would reveal precisely how far east or west he had traveled. The trouble was building a clock that could keep perfect time on a rolling, damp ship, its temperature swinging from the tropics to the freezing north, where ordinary pendulum clocks were hopeless. It took a self-taught English carpenter named John Harrison decades of obsessive work, but he did it. The marine chronometer, a clock of intricate, gleaming engineering that lost only a few seconds across an entire ocean crossing. With it, a captain could at last know both his latitude and his longitude, his exact place on the open sea. The greatest problem in navigation had finally been solved. Out on the deep water, sailors now had the stars, the compass, the sextant, and the chronometer. But the most dangerous moments of any voyage often came right at its end, where the sea meets the land. To guide ships safely past hidden rocks and shallow shoals, people built lighthouses, tall towers crowned first with fire and later with brilliant lamps and lenses that hurled a beam far out across the dark waves. The first of the great lighthouses, the Pharos of Alexandria, stood more than 2,000 years ago and was counted among the wonders of the ancient world. And where no rock could hold a tower, sailors anchored lightships, small vessels with a single lantern fixed high on the mast to mark a hidden danger and warn others away. One steady light in the night could mean the difference between a safe harbor and a shipwreck. For thousands of years, finding your way across the ocean meant reading the world itself, the shape of a coastline, the height of the noon sun, the long swell beneath the hull, and above all the slow, steady wheel of the stars. Generation after generation added one more piece, the compass, the chart, the sextant, the clock. Today we cross those same oceans guided by satellites circling silently overhead, finding our position in an instant without ever glancing at the sky. But every one of those satellites is doing exactly what a Polynesian wayfinder, or a lone helmsman, once did with nothing but patience and the stars above them, answering the oldest question of the open sea, which way is home? If you enjoyed this, subscribe, and we'll keep uncovering how people really lived before the modern age.